here's your video explanation for your review. I'm going to give some key information, highlight some things, walk you through some problems. I'm not going to do all of them, hoping that as I guide you can remember what to do and you can apply that to the ones you have to do on your own. So I put on this review some things to help you what to focus on and memorize. Although the Pythagorean theorem is on the formula chart, so this is on the formula chart, knowing how to determine when it's acute and when it's obtuse is very important. So if it's a right triangle, then c squared is going to equal a squared plus b squared. Now some people change the order, but I try to go with always c squared first, okay, because that's your hint. Always identify the c side first because c is always the biggest number. So that helps you identify that number first. So to determine if it's acute, then c squared is going to be less than a squared plus b squared. So you need to memorize the formula for acute, okay? To determine if it's obtuse, then c squared is going to be greater than a squared plus b squared. And so if you start with your c, it kind of goes together. If it's less, then it's little, then it's acute. If it's greater, then it's bigger, then it's obtuse. All right, so for the first three, we're going to determine if it's right, acute, or obtuse. So the first thing is identify the c, which is your biggest number. So here is our c, the 48.9. You're going to need a calculator for this, so make sure you know how to use your calculator. I'm going to show the keystrokes for the calculator we have in class. So we're going to first write c squared, compare that to a squared plus b squared. The other two that remain are your a and b squared. Let me make that a little nicer. Apologize. A squared plus b squared. All right, so we already know that c squared is our 48.9. We're going to square that. We're going to compare that to our 32.5 squared plus our 36 squared. So in case you forgot how to do that on the calculator and you need just a refresher on the keystrokes, because I'm going to do that for some of these problems. If I want to square, well, first we're going to go to a new document. We're going to add a calculator. And so we're going to square our 48.9. Now, if it's just a decimal and your exponent's on the last digit, it's going to square it. And notice it puts it in parentheses because you want to square that whole constant. So we know that is 2391.21, okay? And then we're going to square our 32.5. Get that number. And then our 36 squared. Get that number. So we're going to write these numbers on our paper here. So we know that our c squared end up being 23, and I'll show you a shortcut, 2391.21, okay? And we're comparing that to the remaining, the sum of the other two legs. So we had 1056.75 plus it was 1296, okay? All right, so if I add those together, this ends up being 2,352.75. And then I'm comparing that to what we had here, 2,391.21. Well, that is bigger. So if it's bigger, then we have an obtuse triangle. Okay, so the answer is obtuse. All right, so let's do the same, and we're going to do it shorter keystrokes. But we see this is our C, that's our biggest number. Write it out. This is how you get partial credit. You set up the converse. So 53.5 squared. Compare that to our 31.5 squared plus 35 squared. This is where you can get partial credit. Now, we know you can go to your calculator here. So if you want, you definitely have to do the c squared by itself. So we definitely have to do the 43.5 squared, get that number. And now I can, since I'm doing the sum of the other two squared, well, we can do 31.5 squared plus our, what was it, 35 squared. So we can put those together. And then I can see the two numbers on the calculator and compare them. I would make sure you write it on the paper so you can get partial credit in case you somehow circle an answer choice wrong or just have the proof to verify. So just by looking at it, I see that the sum is bigger. Okay, so we know, I'm just going to show it. We have this is 892.25. Oops. And we knew the sum over here was our 2217.25. This number here is less than that number there. So since it's less than, it's a Q. Okay? All right. So try the last one. Okay? First, always identify your C, the biggest number. That is here. So now we're just comparing the C squared. I always start with the C. Compare the C squared to the sum of the other two, A squared plus B squared. So I'm going to write it. You're going to solve it and write down your answer. Okay? Some of you might recognize this one. Now, on our next set, we still have to identify our C first. Now we're just going to find the missing leg. We're just going to use our Pythagorean theorem to find the missing parts, the missing side. So remember that the C is always opposite the right angle. Okay? So if this is C, doesn't matter. The other two are going to be the B, A and the B. Doesn't matter what order you put them. We just know what the C is always opposite the right angle. So we're going to write A squared plus B squared equals C squared. And now we're substituting the parts that we have for A and B. Well, here's my A. That was the 8.5. We're going to square that. My B is the X, so we're just going to keep that X squared equal to C squared, which is our 12.5 squared. And now we're going to solve for X. So when I do that, I get 72.25 here plus our X squared equals, and we get 156.25 as well. All right, to solve this, we gotta get the X squared by itself. So we're gonna subtract this 72.25 from both sides. Well, whatever we do to one side, we do to the other. That will cancel out, leaving you with X squared equals, and when we subtract, we get 84. Now, they want us to find the X, the missing side, so we have to take the square root of that. And so in case you're not too sure, to get to that square root is Control X, and then we're going to put 84, hit enter. And they said to round to the nearest tenth if necessary. Nearest tenth is 1 decimal place. So we look right here, then we look to the right of that. If it's 5 or greater, it is rounded up. Okay, if it's below 5, it stays the same. So this ends up becoming X equals 9, or actually we do approximate. Let me show you that symbol. X is approximately 9.2. That's your answer. All right, so let's try 5. Recognize which part's going to be the C first, and that is your X, because that is opposite this right angle. So yes, we're going to have A squared plus B squared equals C squared. Write your formula first to get partial credit, and then plug in the parts. Well, if I plug this in, doesn't matter. Either one of these could be A or B, but let's plug it in. So we got 12.1 squared plus 12 squared is going to equal to now my X squared. Now you can do that 12.1 squared plus 12 squared on the calculator in one keystroke. 12.1 squared plus 12 squared, and we get the sum. Let me take this off, sorry. So our sum is 290.41. So we're going to write that sum is 41 equals X squared. But now we have to solve for X, so you have to take the square root. Okay, and once we take the square root, it ends up rounding because it's 17.04, I think. So it's approximately just 17 because we're rounding to the nearest tenth. So that was 17. So like I can, oh, and here's a shortcut. If I wanted to take the square root of what I just entered, I can do Control. There, X squared gives me the radical symbol, and then Control minus. Above the minus sign says ANS. That means the answer of your previous keystroke, and there it is. See, because there is a 4 next to the 0, we can't round that up. All right, so that takes care of understanding the Pythagorean theorem and its converse. Make sure that you study and you memorize this. Okay, that's the key. Knowing C is your biggest, being able to plug in the parts, work backwards sometimes to find the missing step. I mean, the missing part. So that takes care of 1 through 5. I'm going to go into special rights next. Thanks.